In this short video, I will show you how to test a claim about two population means from independent samples using StatCrunch when one sample is given as raw data and the second sample is given as summary statistic. Let's read the following example. Listed in the data table are IQ scores for a random sample of subjects with medium lead levels in their blood. Also listed are statistics from a study done of IQ scores for a random sample of subjects with high lead levels. Where is that table? Well, if you click on the icon, the results from the first sample listed as raw data and the results from the second sample listed as summary statistics will open up. Let's read next. Assume that the two samples are independent simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Complete parts A and B below. This is very important moment. We need to check for the requirements before we do the test of a claim for two population means. The two samples are independent simple random samples from populations that have normal distribution. So the two requirements are met. And the third requirement, that the population standard deviations are not equal and we do not assume that they're equal. Let's proceed with calculations. In the first part, we need to use a 0.05 significance level to test the claim that the mean IQ scores for subjects with medium lead levels, sample 1, is higher than the mean for subjects with high lead levels, sample 2. So our claim will be that mu1 is greater than mu2. Let's look at the choices that we have. Choice A and choice B we will not even consider because null hypothesis does not have equal sign, and we know that null hypothesis will have equal sign. So our choice will be D. Null hypothesis mu1 equal mu2, and alternative hypothesis will be our claim mu1 is greater than mu2. Let's check the answer. Good job. In the next part, we need to find test statistic. We will use StatCrunch to find test statistic. But before, let's find summary statistic for the first sample. Click on the icon to open it in StatCrunch. The data will transfer automatically. Click on Stat, Summary Stats column. Choose column var1. Click on N. Hold the Control key, mean, and standard deviation. I'm going to copy, Control C, place it down here, Control V. Let me shrink StatCrunch a little bit so I can see the data from the second sample. We can close these results. Now go to Stat, T-Stats, to sample with summary. Enter the summary statistic for the first sample, mean 91.545. I'm going to round the first sample to 3 decimals as well, since the statistic in the second sample is rounded to 3 decimals. Sample standard deviation 9.933. Sample size 11. The second sample, sample mean 90.905. Sample standard deviation in the second sample 9.864. Sample size also 11. Let's check the alternative hypothesis sign. Make sure we adjust it. In our example, it's greater than. Compute. Let's copy this data, T statistic and p-value. And we will need to enter these numbers into the answer box. Test statistic is 0.15 rounded to 2 decimals. Nice work. And p-value is 0.441 rounded to 3 decimals. Fantastic. I'm going to close this table and we will read the conclusion. Well, because p-value is greater than significance level of 0.05, we fail to reject null hypothesis. We have two answers with fail to reject null hypothesis choices. Let's look at the table to help us make a decision. Does the original claim contain a condition of equality? No. Do you reject null hypothesis? No. Fail to reject. We say there is not sufficient evidence to support the claim. Fail to reject null hypothesis. There is not sufficient evidence to support the claim. Choice B. Good job. In part B, we will need to construct a confidence interval suitable for testing the claim that the mean IQ scores for subjects with the medium lead levels is higher than the mean for subjects with high lead levels. Let's go back to StatCrunch. The confidence interval is located also in stat, t-stat, to sample with summary, enter the same summary. Sample mean 91.545, sample standard deviation 9.933, size 11, sample mean, I need the table again, in the second sample 90.905, and sample standard deviation in the second sample 9.864, size 11. Let's adjust it to confidence interval. Because the test is right tail test, we will add 0.05 to the left tail as well, which will make our confidence level 0.9. Compute. I'm gonna copy these limits. Let's read how we need to round it to 2 decimal places. The left limit negative 6.64 and the right limit 7.92. Check answer. Nice work. And the last part, we need to make conclusion about the confidence interval. Does the confidence interval support the conclusion of the test? Yes, because the confidence interval contains 0. Check answer. Fantastic. I hope that was helpful.